Hi, today we're going to demonstrate some of the features of the SDL editor. So in this demo, we've read an IBIS model to get the pins for the part, and SmartFrac runs and it creates the auto SDL template. So it found 17 signal match statements and 8 power match statements for a total of 96 pins. So our job with the SDL editor is to organize those. So the first thing we'll do is we'll notice the symbol description file is empty in Part Builder. We're going to open the SDL editor and it's going to tell us no symbol description file selected. Do you want to create the symbol description file from the SmartFrac template? And we'll say yes. So here the SDL editor opens. Across the top we have the SDL file entry, so here is where the name of the file is and we can save it, we can change the name of it. We have some search and replace tools, so we can go to a line number, in here we can enter a search term and search for it, and then we can replace stuff. Going across the top we have these operations where we can save a file, save as, we can refresh the file contents, we can move a pin or a selection up, we can move a pin or selection down, we could delete a selection, we can copy a selection, and once we copy, the paste will become active. We can add the pin match, we can add a comment, we can add a blank row, we can add a preprocessor command like a repeat or a replicate command, we can add a left spacer, we can add a right spacer on the current line, we can add a new symbol section or a balanced symbol sides. This is a new symbol start, this is a symbol end. This button lets us take a whole selection and select the side for it. This button lets us take a whole selection and modify set modifiers for the selection. And then this button here lets us select a build operation, so we can build the symbols, we can read the pin report. Typically we fill out the SDL, we save it, and then we build the symbols from here. If we come over to the side, we can click in here and we can see we can move up and down. And in this area this is where a symbol starts. It's highlighted with a signal symbol equals, and it ends down here with a semicolon. Here is a power symbol, and this is what the SmartFrac template created. It created a power symbol where it put all the power pins and sets it up so we can choose the side for them. And then the signal symbols, and these are the 17 pin matches that it showed us about. So it found the address pins 15 to 8. It had broken into 2 buses, 15 to 8, 7 to 0, the bank address, the cast, clock enable, clock, DQ 15 to 8, DQ 7 to 0, the LDM, LDQS. And then let's look over here. So if we select a line, we can also right click, and all these options from here are also available spelled out on this side. So the save button is equal to save, the save as is save as, we have the move selection up down, delete, copy, paste, we can add a pin match, comment row, blank row, pre-proc, we can add a left spacer, right spacer, new symbol section, symbol start, symbol end, set the side for the selection or set the modifier for the selection. Now the selections are very powerful in the SDL editor because we can take pins, we can regroup pins by selecting the DQ 15 to 8, which goes with, I know it goes with UDM, so we're going to use, we're going to click that, we'll control click the UDM, and we'll control click the UDQSP. So we've chosen 3 pins, and we're going to cut them, and then we'll paste them. And what happens is it regroups the 3 pins together now. So we can cut them, and move them around and paste them. So we also know that the LDM and the LDQSP and the DQ7 to 0 go together. So let's control click, cut them, and paste them. And now we've reorganized DQ7, LDM, LDQSP, and then the DQ15 to 8, UDM, UDQSP. So let's start organizing this guy. So what we're going to do is we're going to call this DRAM control and data, which will be the name of our signal. So this is the signal name, and any matches that appear between here and this semicolon here are going to appear in this symbol. So on the left we're going to have A15 to 8 and A7 to 0. So what I like, and then there's a bank address. I like to put a spacer between that. So we'll put the spacer on the left between those two and separate it. So now let's put CAS, and let's find RAS, reset, write enable, chip select, and clock enable. Those guys all like to go together. So we're going to use the multi-select, we'll cut it, and then we'll repaste it right there. So now we have CAS, clock enable, CS, RAS, reset, write enable. And then let's move clock enable down by the clock. So we're going to cut that and put it right before the clock. Okay, now we have a diff pair, so let's put a spacer between that. We see we're all on the left side, so we put a leftist spacer. The ODT pin, let's use the up and down pin to move that up. So we'll put everything above the clock that goes at the clock above it. And we'll put ODT1 up there. So now clock enable is close to clock P. And then now let's separate the DQs from the CK by adding a balanced symbol sides. And we'll put 2 pins in between that, 2 pin spacers in between that. So now we're going to choose, now we're going to play around and we're going to set sides for this. So because these are I/O pins, SmartFrac assigned it a choose side to let you choose it. So we're going to put DQ7 on the left, we'll put the LDM pin with it on the left, and the LDQS pin we'll put on the left. We're going to put DQ15 to 8 on the right, which will end up lining up right with DQ7 to 0. We'll put UDM on the right, and we'll put UDQSP on the right. And then we'll save it. Now let's go work with the power pins. So what I like to do is I like to find the biggest power pin and start with VDDQ. So I'm going to take him and move him to the top. And I'll put VDD on the left, and that's going to take care of 9 pins there. SmartFrac found the VDD in the pin list and it knew there was 9 pins with it. The VSS is his companion, so we're going to delete that. We'll move it up and we'll paste the VSS pin in there. So now for power symbols, since we have a group like that, let's balance symbol sides between them. And then we could put like 3 spacers so that between VDD and the next group of pins we'll have enough room for decoupling caps. We'll put VSS on the, so VDD is going to be on the left, VSS we'll put on the right. We'll have 3 spaces between the next. So let's find VDDQ and VSSQ and group them together. We'll control click, we'll cut them, we'll put it, move up to below this balance sim sides, and we'll paste. Move VDDQ to the left, move VSSQ to the right. And then we'll put a balance symbol sides to separate the next section. Let's put 2 spaces there. And then let's put NC on both sides. Now the VRef should go along with the addresses, so I'm going to move it from the power body. From here, I cut it, and I'm going to put it right under the clock, after the clock and before the balance symbol sides. So I'm going to paste the VRef CA right there, and let's put a spacer on the left between the clock and that VRef pin. Let's put the VRef DQ by the VRef pins, by the DQ pins. So now we're going to do this. We'll put a balance symbol sides to separate it, and then we'll take the VRef DQ, and we'll actually take the ZQ pin, which is the resistor to set the impedance on a DRAM. So I'm going to cut those. I'm going to move this here, paste, and we'll put the VRef DQ on the left, and we'll put the ZQ on the right. And we need to set aside for the VRef CA, so we're going to set it to the left. So now that we finished that, we're going to save it. And that is all we had to do to edit all those pins in the SDL editor to organize a symbol. So we're going to have what's going to end up happening when we build it, we'll have a DRAM controlled data symbol and a power symbol. So let's run and build the symbols. And we can see it completed, and now let's view it. So we'll view the symbol, and we can see, let's hide this window for a second, and then pop up real quick. And let's look. So we had A15 to 8 on the left, then we had A7 to 0 on the left, we put a spacer on the left, we put bank address 2 to 0. You know, I would like a spacer there, wouldn't you? So let's go here and insert a left spacer. Okay. We have CAS, CS, RAS, reset N, write enable, ODT, CKE. Let's move CS down too, because I think it should be closer to the clock pin. It's where you want it, so we can use the move pin, and we'll put it right above the CKE. We'll save that. So let's regen. Close that. Part builder ran again. We'll view the symbol, and now we can see, okay, so the spacer we added, and then we move CS down above CKE, and we have all our controls. So this is a pretty nice looking symbol. And here's our DQ7, LDM, LDQSP. I think we should probably separate the DQ buses. So let's go add some spacers. Here's our DQ7 to 0 and our DQ15 to 8. So let's move the DQ15 to 8 up to here and put a balanced symbol sides in here. So now that'll give us DQ7 to 0 on the left, DQ15 to 8, and then we'll put a spacer of 1 on both sides with the balanced symbol side. And then we'll put the DM, the LDM and UDM together. So let's move the UDM up and let's do a balanced symbol sides there. And we'll save that. And let's go back and build it again. And here we see it run to completion. And we'll view the Allegro symbol again. And now we have a space between the LDM and the UDM, and we have a space between the strobe. So now that's organized pretty well. And we have our VRef DQ and our ZQ. And then let's look at the other symbol. So we also created a power symbol. And that looks just like we expected. We put the VDD on the left, the VSS on the right, the VDDQ on the left, the VSSQ on the right, and the no connects on both sides. And here's the amount of space we have, so we can add wires and add decoupling caps when we put it in the schematic. If we want to increase the space between these, we just go increase the number here, or the number here. So we put 3 spaces between that, and let me pop that up one more time. So we have the 3 spaces between this. So balanced symbol sides looks at it and says, okay, there's more pins on this side, so I'm going to add spacers on this side until I get to here, and then I'm going to add 3 more spacers on both sides. So that's why it starts a new section within the symbol. So we created 2 symbols. Let's go back and look at this first one. It looks kind of crowded up at the top, so it's got all the address and control. Why don't we split this into a new symbol, the DQ7? So what we're going to do, we're going to go find where the balanced symbol sides is in front of the DQs. And here we're going to end the symbol above, and we'll start a new symbol here. So we're going to use this, which gives us a new symbol name, and we'll call it DRAM. And if I could type, you'd be fast. This demo would be faster. With DRAM DQ, we can get rid of this balanced symbol sides because it's a start, and we'll save it. And then let's run one more time. Build symbols, we pop up. So now we can see in the status window that we built 3 sections: DRAM control data, DRAM DQ, and power symbol 1. There was 29 signals in the DRAM control, 34 including spacers. We detected 24 signals for DRAM DQ, 32 including spacers, and then 43 for the power symbol, 56 including spaces. And let's look at what we created. View. So here we separated. Here's our address, bank address, CAS, RAS, clock enable. And here's our DQ symbol. So now the data is on another body. Simple as that. And there's our VDD, VDDQ, and NC, so the power symbol. Thank you very much for watching this quick demo of the SDL editor in action.